Okay, so this is one of the most important conversations we're going to have in the risk and return context, because now I'm going to introduce the model that basically allows us to, given a certain amount of risk that we measured, to determine how much return we should require. Okay, but before we get to that model, which is we're going to call the capital asset pricing model, or CAPM. Okay, so CAPM for short. Okay, capital asset pricing model. Let me just go through just the logic for a second. Suppose that you invest, okay, so you invest in the market. So what does it mean to invest in the market? It means that suppose you buy a fund that replicates a stock index, okay? So you're spending a certain amount of money in an asset, right? An investment that tries to behave in the same way as your market does. If you, no matter where you are in the world, right? If I go back to the same examples that I've been using so far, if I am in the U.S. context, yes, I will be investing in an asset that mimics the Standard & Poor's 500 or the S&P 500. Okay, so I'm investing in what we have called the market. Remember, the market for us is basically a stock index that reflects how the stock market is doing, and that's what we consider to be a good representation of the overall economy. Remember, it's not a perfect representation of the overall economy, but a good one. All right, so if I invest in the market, what will be the risk that I bear? What will be the beta for that? Remember, what is the beta? The beta is how sensitive our investment is, our company is, to the market. So if I invest in the market, how sensitive is the market with respect to itself? In other words, what would the beta be for something that mimics the market exactly? The beta will be equal to 1. Okay. Previously, we had found that the beta for Google, you may recall, right, was approximately 1.27, right? So this company is more volatile in the market. But if you invest not in the company, but again in an asset that mimics the market, then the beta is going to be equal to 1. So here's the argument. If you invest in the market, given that you're bearing this amount of risk, how much compensation would you need? How much compensation would you expect? And what we do is we say, okay, let's find out what I have historically been able to earn if I had invested in the market. So if you had invested in the stock index for the past 30, 40 years, how much on average, all that time, how much on average would have you have earned? Let's suppose that that number is around 12%. Okay. So on average, you would have earned 12% per year if you had invested in the market. Okay. Now, that 12% compensation is a compensation in return for a risk. How much risk are you borne if you had invested in the market? How much risk? What is the risk? Well, again, as we said, if you invest in the market, the risk, your beta, is going to be equal to 1. Okay. Now, what happens if you invest in a risk-free security? Risk-free security. So in a risk-free asset. What is a risk-free asset? Let's say investing in the government bond. What happens if you invest in the government bond? Let's suppose that on average, if you had invested in the government security, which is supposed to be, a safe security, it's called risk-free because basically, again, that depends on each government, right? But on average, governments would be relatively safe because they can always make their payments because they're not the money machine. If your government is not safe, if you don't feel that that's a risk-free investment, then you could take as a risk-free rate the yield to maturity of a AAA rated company, multinational company in your country, which could be borrowing at a rate that's actually lower than the country rate. The country can borrow. Okay, so we can always find a risk-free rate, right? But in my case, let's suppose that on average, the risk-free return would have been around 2%. For the past 40 years, if you had invested in a government bond, you would have earned, let's say, 2% return. Okay, and that's without any risk, right? So here's my question, right? Why is this difference? What does this represent, this difference between the market return and the risk-free rate? That difference of 10% in my example, what does that mean? That is the compensation, right? For what? If you invest in a risk-free asset, by definition, you're bearing no risk. So if you are investing in a risky security, then that extra, so if you invest at no risk, you will get 2%. If you want to invest in a risky security that has a beta equal to 1, how much would you get? You will get 12%. So this 10% is the compensation for bearing a risk equal to 1, right? So think of this as the price of risk. Price of risk. For every unit of beta, for every beta equal to 1, how much more compensation are you going to require? 10% more compensation. If you had invested in a company that has a beta of, say, beta of 2, how much extra compensation will you want? Well, twice as that, right? Twice as that would be 2 times 10%. If your beta is equal to 3, how much compensation will you require? 3 times that 10%. If 10% is the risk, the compensation for risk for bearing a beta of 1, then all you need to do to find how much return you would require for your company is to multiply that return that times this expected return per unit of risk times the beta for your company. Okay. So I hope you see the logic in the fact that once you find this 10% that I'm calling the price of risk, then all we have to do is multiply that number times the beta, and you get the premium that you should require for your investment. Now this has a very specific name. I'm calling it the price of risk, but the official name is called the market risk premium. Market risk premium. Okay. So I hope that this logic makes sense to you, so that now I can present the actual model. So the actual model looks like this. This is called, the CAPM. It's also, the official name is security market line, but you will hear most people talk about it as a CAPM. So for any firm I, right? Any possible firm for which you have its beta, what we're saying is that the return you would require if you were an equity investor. So this is like we're specifically pricing stocks, right? So if you wonder how much return were you required to invest in the equity to become an owner of a company, the return you were required, this is equity, E is for equity, okay, for an equity investment, is going to be equal to the risk-free rate, today's risk-free rate, okay, this is today's risk-free rate. Okay, so suppose that today's risk-free rate is the yield to maturity for a government bond today is, just as an example, is 1%. Okay, plus what? Plus what is this in parentheses? The difference between the market return on average and the risk-free rate on average. That, remember that we called it the market risk premium. Okay, this is what this is. Right. So in my example, okay, remember that was 10%. That is going to be multiplied times the beta for your company. Okay, the beta for your company or your investment. So let's look at the logic here. All we're saying is that the return you will require from any equity investment is going to be, first, well, what is the return you would earn if you were to invest at no risk at all? Oh, that would be 1%. Today's bond yields are 1%. Okay. But since you are investing in something that's risky, and that risk is embedded here in the beta of that company or that investment, then you're going to add to that 1% a premium, a risk premium that compensates you for the fact that you are investing in something that's risky. Okay, so how do you know how much extra you have to require, extra in addition to this 1%? Well, as we said before, if you have the price of risk and you have the amount of risk of your company, then the multiplication of these two will give you the overall market risk premium. Okay, so if my company suppose has a beta of 2, then what is the return you would require for investing in this company? It would be the 1% plus 10 times 2 is 20%. So you would require an overall 21% compensation. If your company had a beta of not 2 but 3, then this would have been 30%. And so this would become 31% compensation. Okay. So this is the CAPM. This is the logic behind the CAPM. Okay. Now, there's a few things that we do have to be careful about, because, for example, you could argue, all right, but the risk-free rate you told me is a yield to maturity for a government bond. All right, this risk-free rate is a yield to maturity for a government bond, right? This is from government. But the question is, what maturity? What maturity do I use? Do I use a 10-year bond? Do I use a 20-year bond? And the answer to that question is, look, if you look at the assets of the company that you're studying, you're analyzing. If this is a company like a textile company that has long-lived assets, then what is the risk-free equivalent of an investment in long-lived assets? Is it a 5-year bond or is it a 30-year bond? The answer would be, a 30-year bond. So the risk-free rate is a yield to maturity of a government bond whose maturity is as close as possible to the average life of the assets of the company in which you are investing. So if you're investing in a technology firm with, let's say, an average life of 5 years for these assets, then you should be looking at risk-free rate should be the yield to maturity of a government bond with a maturity of approximately 5 years. Now, don't worry about the fact that companies. I know what you're thinking. You're probably saying, well, but companies, even though their assets are only 5 years, they exist for longer amounts of time. True. All we're saying is that investing in this company is you continuously reinvest in assets, right? And that lasts around 5 years. All we're saying is that the risk-free equivalent of investing in the type of assets that your company holds is a 5-year bond. It doesn't mean that your company is going to last only 5 years.